Okay, welcome to another podcast based on conditional probability. Conditionality really deals with kind of an if-then notion. So if some condition has to be met, some given condition, then what's the likelihood or the probability of the event occurring? So the conditional probability formula that is in your formula booklet looks like this, and part of the objective of this podcast is to unpack this to get a sense of what it's trying to say and also introduce the notion of a tree diagram. The way one reads this, just for starters, is what's the probability of A given B took place? And the probability of A given B will be, as it turns out, the probability of A and B divided by the probability of B, because if B is the given event that had to take place, it reduces the pool of possibilities. So let's talk about a specific example, build on it, and actually see lots of notation, which you may or may not have to use given your approach with this. So what if is a bag containing 5 discs, 3 of which are red, which means 2 are non-red, and a box contains 6 discs, 4 of which are red, and therefore 2 are non-red. So a card is selected from a standard pack of 52 cards. More on the next slide about a standard pack of cards. If the card pulled is a club, then we reach into the bag. If the card is not a club, then we reach into the box. So the beginnings of a tree diagram concept is emerging here. So we need to find the probability that the disc removed will be red, which means we could either get that red disc from the bag given we pulled club, or we could get that red disc from the box given we don't pull club. And then the new thing that's highlighted in red deals with conditionality. We have to find the probability given the removed disc in our hand, if you will, is red, what's the chance that it came from the bag? So let's pull all of this apart. Here is a nice structure. So if I'm not sure if you're familiar with a standard pack of cards. We'll come back to that in a second in terms of, well, I actually showed you that in a previous podcast. Sorry about that. Where you've got either a club, a spade, a heart, or a diamond. So you've got 13 so-called suits. 13 times 4 makes for 52. So there are no jokers in this deck. So your chances of pulling a club, if you will, from that deck of 52 cards is 13 chances out of 52, which reduces to 1 out of 4. Your chances of not getting a club, and it's nice to use this kind of complement notation, would be 3 chances out of 4, and these always have to sum up to give you the value of 1. So once you reach into the deck of cards and pull club, you're now reaching into the bag, and you have 3 chances out of 5 to get a red disc from the bag, or 2 chances out of 5 to not get the red disc. Given you did not pull club, then you're reaching into the box, and you have 2 chances out of 3. That's what the values there reduced to pull a red disc, and therefore only 1 chance out of 3 to pull a non-red disc. So let's start to show you some notation. The more you can communicate and use some of that, the better. So what is your chance of pulling club and then pulling a red disc from the bag? Well, that would be the product of these two. And so therefore, your chance of club and red looks like 3 chances out of 20. Your chance of club and non-red from the bag is the product of those two. You get the idea. And similarly here and here. So as it turns out, if you were to add 3 20ths, and this of course would be 2 20ths, so there's 5 20ths. This looks like 10 20ths, and this is of course 5 20ths. If you add all 4 of those, they will also sum up to be the value of 1, which is a requirement and a good control on the system. So, and that's highlighted for you right here in terms of the sum of these guys looking like this relative to being 1. So let's talk a little bit more about this notation here that I've highlighted in yellow for you. So firstly, what you see in green, which is the 1 chance out of 4, well, that's simply the probability of pulling club, right? That's non-negotiable. However, this guy here, notationally, he's the chance of pulling red given you pulled club. So that starts to introduce some new notation. And then the probability, as already stated, of pulling club and red, in this case from the bag, is the product of these two. So these 3 colored dots are corresponding, as you can see, to these 3 notational forms down here. So basically, this 1/4, which is the probability of pulling club, times this 3/5, which is the probability of red given I pulled club, that's actually equal to the value here, which is your 3/20. So the product of these two, giving you this structure here, allows you to say, well, what if I wanted to isolate just the probability of pulling red given I pulled club? Well, that would mean I'd be dividing this value over to the other side. So you get this formula here, which is my way of backdooring us into some understanding of this probability formula here. So notice I just sort of confirmed for you the probability of pulling red given I pulled club is just the probability of C and R. Well, if you put A and B there, it's A and B. Divided by what? Divided by the probability of just pulling the chance of, well, the given condition of the club. So the given condition of the probability of B is what you see here. So let's return to the problem and solve both A and B. The chance that the disc removed will be red, well, you pull club and then you pull red, or you don't pull club and then you pull red. So not surprisingly, 1/4 time, well, actually notationally your chances of getting red would be what I just described. The chances of pulling club and then red from that particular place, added to that the chances of not pulling club but yet getting red from the other place. So the product of these two we've already seen, plus the product of these two accounts for the fact that there's 13 chances out of 20 to actually have a red disc in your hand, having that disc coming from either the bag or the box. So let's move on to the new stuff, which is the probability that if that removed disc in your hand is red, so that's the given condition you have to meet, that it came from the bag. This is the general formula that's in your formula booklet. I would strongly recommend you try to notationally represent in particular form what you need. So the if statement here, the given statement, is that given it has to be red. So again, this is read as, one reads this as the probability of A given B. So the given condition controls the denominator. So if the given is that the disc removed has to be red, then that's what's going to control the denominator. And then of course, once you're structurally establishing what's the probability of basically pulling a club given it's red, because that's how I'm in the bag. So then the sort of and of these two goes up top. And so that kind of helps you get some kind of structure to what's going on. So if we're looking for the probability that I pulled a club given I have a red disc in my hand, well, the probability of a red disc was actually already established in part A. That was 13 chances out of 20. And the chance of just club and red is just this sort of branch of the tree here, which is the product of those two. So the 3/20 divided by the 13/20, of course that's multiplication by the reciprocal. You get 3 chances out of 13, and essentially you've been reduced in terms of the field of possibilities here because of the given condition that it has to be red. And you can find that 13 actually in here if you think a little bit harder about it. So let's conclude with a Venn diagram setting and look at conditionality as well. Sometimes the formula can be useful within a Venn diagram setting. Sometimes most often you can just use logic to establish a reduced pool of possibilities to meet that given condition. So we're a class of 29 IB students, 20 study chemistry, 15 study bio, and 8 study both. So you can already kind of see an overlap, and that's really often the best place to start within a Venn diagram setting. So a student selected at random. Let's first write down the number of students taking neither course, and then we're going to find the probability a student studies chem given he or she studies bio. So if he or she studies bio, then what's the chance they study chem? That's the conditionality. Same idea here for part C. We'll come to that question in just a second. So here's your setting. You know you have 8 here in the middle, and you know that you had 20 who were studying chem. So 20 minus the 8 already accounted for there. These are pure chem takers, with 8 of those chem takers also taking bio. And the same idea here to break down the 15 bio students, since you've accounted for 8 of them already here. So here's our bio world. You've got 7 here. And then once you add up, here's your 27 altogether. And so there's only 2 left over out of the 29. So that's a pretty straightforward way to get the party started. In part B, we need to find the probability. The student studies chemistry, given he or she studies bio. Let's cut right to the chase. The given regarding he or she studying bio, that puts you into this world here, because that's our bio world. So to meet the given condition, once again, in general, the pool of possibilities is reduced. So what's the chance you study chemistry? So here you are as a person studying chemistry, given you're also a bio studier. So 8 chances out of 15 is the answer. Worth noting, if you wanted to attack it formulaically, once again, what's the chance of studying chemistry? So what's the probability you study chemistry given you are studying bio? That structure from your formula booklet will allow you to put the probability of bio down bottom, and this becomes a C and B notational representation here up top. So what is the chances of studying chemistry and bio? Well, if you're studying chemistry and bio, you're right here. You're 8 out of the overall 29. And if you're just studying bio, it looks like you are these 15 out of the 29. The 29s cancel, and there's your 8 out of 15. So the formula still holds up. Lastly, and then we're done, find the probability the student studies both science courses, given he or she studies at least one. That's a little bit more wordy, but your chances of studying both, you're right in here. Given you study at least one, well, these people are not studying any, so the people studying at least one are these people here, here, and of course these people here, because at least one can also involve 2. So here's 27, and so 8 chances out of 27 is the final result there, just again non-formulaically. The notation describing that, it's actually in some books that I've seen. You know, what is the chance of you, the probability of you sort of studying chemistry and bio given you study either? That's kind of what it is notationally, but you don't need to actually go that route. You can just use the pure logic of the approach here. With Venn diagrams, it's very often more advantageous to just think in terms of a reduced pool in terms of that given notion. Okay, that's it. Thanks for listening. Good luck.